This is the introduction to section 10.7, part 1, where we're talking about areas of circles and sectors. And here in part 1, we're going to talk about finding the areas of circles and sectors. That's going to be the first part. Okay. So we've talked about circumference, and now we're going to we talk about circumference. We're talking about the distance around the outside. Now we're going to talk about the area, which the area is essentially the inside of the circle. Okay, it says here you can find the area of a circle when you know its radius. You can use the area of the circle to find the area of part of a circle formed by two radii, and the arc of the radii formed when they intersect with the circle. Okay, so let's talk about area of a circle first here. To find the area of a circle, we've got the formula here. The area of the circle is the product of pi and the square of the radius. So in other words, the area of a circle is pi r squared. It does not have an option for the diameter. So if you know the diameter, remember the radius is equal to the diameter divided by 2. So you're going to have to be able to do that in some of these, where you're going to have to take the diameter, divide it in half to find the radius. Okay, so let's take a look at the examples here. It says, what's the area of the circular region on the wrestling mat? You'll notice here that in the picture we have a center right here, and we have a diameter here of 32. So if our diameter is 32, our radius would be 16 feet, because we divide that in half. So then we want to find the area, so the area is going to be pi r squared, or it's going to be pi times 16 squared. 16 squared, remember it's not 16 times 2, it's 16 times 16. So this ends up being 256 pi. And in this case, my units are feet squared. Again, we're finding areas now, so the area is in square units. Now, that's if they want you to leave your answer in terms of pi. If I were to leave my answer rounded to the nearest tenth in terms of a decimal, I'd take 256 times pi on my calculator. I would get 803.8, in this case, feet squared. So again, you have to be prepared to do it with both ways. Okay, two more examples here. What I want you to do is hit pause on your video, find the area of these two circles, and then see if you get them correct by playing them back later. Okay, now that you've hit pause, let's take a look here. Again, my radius in this case is going to be 4 because my diameter is 8. I take the diameter divided by 2. So the area is pi r squared, which is going to be, in this case, pi times 4 squared, which is going to be 16 pi, in this case, feet squared for my units. And if I find that, that's if the answer is in terms of pi. If the answer is rounded to the nearest tenth, this would be 50.2 feet squared, 16 times pi. Okay, the second one here, the area, again, is equal to pi r squared. My radius is 8, or half of 16. So my area is pi times 8 squared, or it is 64 pi centimeters squared. That would be my answer in terms of pi. If I round it to the nearest tenth and find the decimal, it would be 201. It'd be 201 centimeters squared, 201.0. It's actually 200.96, which is going to round it up to 201. Okay, now that we've found the areas of circles, we're going to find what we call the areas of sectors, or excuse me, in this case, we're going to find the area of a shaded in region of a circle. In other words, we're going to find the area of a piece of pie, if you treated this as a pie. So the area of a sector of a circle is the product of the ratio of the measure of the arc divided by 360 and the area of the circle. So again, here's the formula for the, in this case, the area of a sector. So we would take the measure of arc AB In other words, in this case, in all of these are all central angles, so they'll be fairly simple to find. Divided by 360 times the area of a circle. This is a little bit different than finding the segment of a circle, or finding the, in this case, a little bit different than finding the arc length. Okay, now we're finding the area of this sector. So, let's take a look here at these bottom two examples. What's the area of sector GPH? So we want to find the area of the shaded in region. Well, you'll notice that the area of the sector, in this case, the arc GH is what we're looking for, so that's 72. Going to divide that by 360. Take that times pi, times the radius, which in this case is 15, and square it. So if I take 72 divided by 360 on your calculator, you'd end up with 0.2 times pi times 15 squared is 225. Okay. So if I take now 225 times 0.2, you end up with 45 pi centimeters squared. That's if you want your answer in terms of pi. If you want your answer in terms of a decimal, you take that times pi, and rounded to the nearest tenth would be 141.4 centimeters squared. Very similar to finding arc length, but it is a little bit different. You're not using circumference, you're using the area. So, the area of the second sector, what I want you to do here is hit pause, and then see if you can figure this out, and then hit play to see if you get the answer correct. Alright, now that you've hit pause here, let's take a look here at this answer. Our arc length that we're looking at here, the arc is 75 degrees divided by 360 times pi times, in this case, our radius is 9 squared. Well, 75 divided by 360 gives me a decimal of 0.2083333, so I'm just going to write this down. This is from my calculator. Times pi times 81. 9 squared is 81. Remember, that's not 9 times 2. That's 9 times 9. So then when I take that number times 81, the 0.2083333, I get a number of 16.9 pi. In this case, it's inches squared. Again, that's what your answer would be in terms of pi. If I wanted to calculate the actual answer, 16.9 times pi, the answer rounded to the nearest tenth would be 53.1 inches squared. So that's the area. That's the area of this little yellowish type region of the circle. Alright, this concludes section 10.7 part 1. Don't forget to complete your WSQ at the end.